Hi, and welcome to another presentation of a video solution presented by ProModel Corporation. We have a model that today is going to show you how to process multiple entities coming in varying quantities, and then being able to process any leftover entities, and we'll get into more details of how we're going to be doing that in just a minute. This solution can be found on our Solutions Cafe. It's titled Loading Leftover Entities, and we will go through this model and demonstrate how you can process this type of logic that we're going to be looking at. First thing we want to do is talk about some variables that we have defined. So I'm going to just click our variables icon. You can also view any of these icons in our toolbar by going to the build menu, and here we would have variables, but I just clicked the toolbar icon right here. So the only thing I want to talk about with the variables is to make note that they are all defined as integers, and I'll explain in just a few minutes why that's important. We don't need to worry too much right now about what these are called, but just the fact that they are defined as integers rather than reals, so whole numbers instead of decimal values. Alright, now that we've talked about the variables, let's go to our arrivals. Our first entity that we have arriving is called batch, and what we're going to be doing in the model is have several batch entities arrive, and we're going to have them arrive in different types or different sizes of quantities. So in our logic, we have an attribute called a batch size and assigned a uniform distribution with a mean of 23 and a plus or minus of 7. So our batch size is going to be anywhere from 16 to 30 entities on each arrival. Then we also have boxes that are going to arrive. There's our box entity, and we're only going to have one of those arrive. So on the batches, we're going to have 10 arrivals every 30 minutes, and for the boxes, we'll just have one arrival. Now let's look at our processing logic. And again, you can click either on the toolbar icons or go to the build and then processing. That would bring you to the same spot. Now the first thing we're going to look at is where our batch entities arrive. They're going to be coming into this open batch location, and let me just open up this operation logic, stretch that out a little bit so we can see it, and I'm going to be explaining the logic that we have in this model to be able to process any leftover entities that we have from our batch sizes. In this particular model, what we're doing is we are loading our entities into boxes, and we're going to assume that our box can only hold a maximum of 5 entities. So for example, if we have 23 entities come in our original batch size, we can put 5 entities in a box, so that means we can have 4 boxes that are full, and we're going to have 3 entities left over, and we need to know how to process those extra 3 entities. So that's what this logic is going to be doing. First of all, we have a wait until statement that says wait until VBox is in process is equal to 0. And the only reason for this statement is to make sure that we know what our batch sizes are going to be, how many are going to be left over at the end after we finish packing the boxes full, and then we want to allow additional batches to come in and be processed. But we need to be able to control when those entities come in and when they move through the other steps in our process. So this wait until statement is going to give us the ability to do that by watching how many boxes we have in process. So the first thing we do after that wait until is we set a variable called v full boxes needed equals a batch size divided by 5. Again, 5 being the number of entities that can fit into a box to fill it up. So whatever that batch size was that we set in our arrival with that universal or uniform distribution, that's going to be divided by the number 5. And here's where the integer type entity comes into play. Because v full batch size needed is an integer, if there's any remainder in this division process, all we're going to get is the integer portion. So again, if we have a batch size of 23 and we divide 23 by 5, that's going to be 4 with some number in the remainder. But because v full box is needed is an integer, that division process is only going to put the integer portion of the division into that variable. So again, with the number of 23, v full boxes needed will be 4. Then in order to find out how many are left over, we use this next statement where we say v leftover units, which is again is an integer variable, equals the batch size, and here's the key, mod 5. So the mod function will give us the remainder from this division. And going back to our batch size of 23, batch size of 23 divided by 5 gives us a remainder of 3. So the value of 3 would be loaded into v leftover units. So that tells us how many units are going to be left at the end of our processing that will go into a partially filled box. Then in our next statement, we look at the value of v leftover units. If that value is 0, meaning this number divided evenly, meaning 5 divided evenly into our batch size, then what we're going to do is say batch v box. What we're going to do is say that v box in process equals v full boxes needed. So this calculation that we did up here, that becomes the same as v boxes in process. If there is a remainder, then we go down to this else statement and we say that v boxes in process equals the number of full boxes plus 1, because we're going to need that extra box for the leftover entities. And once we've set those variables, we can order the number of units that we need. So remember in our arrival, let's go back to our arrival, we're ordering just one entity and determining our batch size there, but we can't load boxes with just one entity. So what we're doing in this logic is ordering the actual number of entities that we need for our order size or our batch size. So we're going to place that order and we're going to send it to the hold location. And then I've just added this display statement here so that we can see what our batch size is, how many boxes there are going to be, how many full boxes, and how many leftover units there are. So this display isn't required for the model processing, it's just for information so that we can get a warm fuzzy feeling about that the model is working correctly. So our next statement, let me open our move logic. This is in the routing section. So in this window we have our processing, and over here we have our routing. I'm just going to open up this window so that we can see both our processing logic and our move logic. In several lines of our move logic, I have a move statement. The only purpose for that move statement is so that we can visually see the entities moving. Again, this is kind of like our display statement. It's not required for the model to work correctly. It's just for visual representation so we can see the entities actually moving. So if we go to our next process record. This is where the entities are being ordered to. We're not using any processing logic here. We're just using another move statement so that we can see things moving. Then in our next processing line, we have our box entity coming to a box queue where it's going to be arriving. And again, no processing logic required there. But in our move logic, this is a technique that the beginning modeler may not be aware of, but it's good to know. If you want to have a continuous arrival showing up at a location in the model, this is one method you can use to do that. Every time the box entity comes into this box queue location, it doesn't do anything in the location itself, but when it moves out, it orders a new box. So basically we have a perpetual order going on. Anytime the box leaves that location, it orders another box to that same location. So that gives us a continuous arrival of boxes coming into the model. So we go to our next step where we package the batch entities into the boxes. So the first thing we're going to do in this process step is we're going to wait until VBoxes in process is greater than 0. Remember, in our first statement, we waited until the VBoxes in process was equal 0. That was to make sure that only one batch was getting into our boxing process at a time. But once we actually get to the location where we want to put entities into the boxes, we want to wait until there are actually boxes available to start packing. Then our next step is we say if the full boxes needed is greater than 0, meaning we have at least 5 entities in our batch that we want to put in a box, then we proceed through that if and we load 5 entities or 5 batch entities into a box. Then because we've completed one box, it's totally full, we are decrementing the number of full boxes needed in our process. Once we've gone through all of the full boxes that we need, this if statement would be false, and we would drop down to the else statement. So else if leftover units is greater than 0, meaning we have a remainder left in that division that we did initially. Remember, we did a 23 divided by 5. That gave us 4 full boxes and 3 remaining entities. So if the V leftover units is greater than 0, in this case it would be 3, then we would load those 3 units into the box. So if we have at least 5 units, it'll take that first statement and load the 5. If there's any remainder, then it will go down to the else and load the remaining boxes. Then in our move logic coming out of that loading location, we decrement the number of VBoxes in process. So let's say we had, again, the 23 batches in our initial order. That would give us 4 full boxes and 1 partially filled box. So each time we finish loading a box, we want to decrement the number of boxes that we have remaining. And once we've finished that last box, we go to the shipping location and we just wait 1 minute again for visual purposes so that you can see what's going on. So let me just run this model so you can see how that's going to work. So here's our display statement that I said was just in there for validation that our model is working. So our batch size from the uniform distribution that we created in the arrival is giving us a value of 21. 21 divided by 5 is 4 with a remainder of 1. So we're going to have 4 full boxes and 1 box that's partially full with only 1 entity in it. So if I just OK that display message, you now see the boxes coming in and the next order comes in. So in this case, we had a batch size of 24. 24 divided by 5 is 4 with a remainder of 4. So when I click OK, you're going to see 4 batches come into a box, and then the 5th batch will have a quantity of 4. Now, the reason you're not seeing the individual entities being processed at this hold units location was because we used a load statement. So once it hits that load statement, it converts those 5 entities that are being loaded into a single entity, or a batch, or a group. So what you're seeing is that batched entity or grouped entity leave this location, go into the box, and then the box moves on. So again, we have a batch size of 22 divided by 5 is 4 with a remainder of 2. And there's our 5 boxes. And because we have that continuous arrival of boxes, you're always going to see a box waiting, and as soon as the last box in our batch moves on to the shipping, that empty box is going to come back up. So 21 divided by 5 is 4 with a remainder of 1. And there we have our next box waiting. So that is one method you can use to find out how many extra entities you have after you've processed a fixed batch size. And also we demonstrated how you can have a variable number or variable size of a batch coming into your model, and then be able to find out how many are left over and then process those leftover entities. So we appreciate you watching this model. We hope it was helpful for you. Again, this model can be found in the Solutions Cafe with the title of Loading Leftover Entities. And there are also other solutions there that should be able to provide you with many answers to your questions in modeling questions and other issues you have as you build your models. Thanks for joining us.